it going, everybody? Shane with Scorpion 6 Knives. Want to go over more information for our Tip Tuesday. When we took the surveys, some of the questions we had were regarding the lockups on knives. Lock face angles, reasons for lock slip, rock and stick, early versus late lockup, and then frame lock design over travel guards, lock inserts, and things like that. So in this video, I'm going to go over lockups on our knives, as well as just some principles and foundations on other knives. Let's check it out. All right, welcome everybody. Going to go over lockups. Something I don't usually enjoy about other kind of how-to videos is the maker always talks about their own brand, their own knife. They explain how they do their locks different than everybody else, and then the thing, it's kind of like why they do independent testing, because I can be like, oh well, this is totally normal, and anyone else that doesn't do it, it's wrong, and then try and make my knife look superior to others. And I don't want to do that. I want this to be an unbiased video. So I'm just going to go over lockups, how they work, how they're designed, and then go into the basics of troubleshooting, common failures, and different features. So to begin, I'm going to start with what is the lock. This is kind of the whole deal as a whole. So these knives, all minus this one, are frame locks. And what that means is a part of the frame itself. These are titanium. The nice thing about titanium is it's spring steel, so it keeps that tension over. So these are frame locks, meaning a part of the frame is torqued over, and that is what keeps the blade from closing once it's been opened. And as you look into here, as it opens, it is the frame lock, frame locking. I brought this one out. This is the Steelcraft Beg Glimpse. This one has a liner lock. It's the same principle. The piece of material is inside of here, and then it's spring loaded over, so when the knife opens, it locks into place, keeps the blade from closing on the hand. Same principle, just different style. That's the only reason this one was out here, just to show that difference. So that is a frame lock. There it is. So to get into designs of locks, there's a couple different features. On a Scorpion 6 knife, we don't have CNC here. We don't have electronic mills or anything like that. This is all done by hand. So for us to do dramatic machining here would be extremely time sensitive. There's more materials involved, just more steps involved, and we're trying to keep the price point where it's at. If we were to spend an extra hour or two doing inserts and things like that, this would be very difficult. So for ours, we have the detent, which is placed on the other side of this hole, and then the lock bar, this portion, and then the lock relief. This relief is what creates the amount of tension going to the lock. So if you mill more of this away or grind more of this away, then your lock is going to be weaker. If you leave it too thick, your lock is going to be stronger. And then you bend it over, and that's how you get your lock. Now this is a Skike Rogue Shark, and on this knife he does the same thing. He has a relief. This one's milled larger, but it is a larger handle. It is a different thickness, but it's still the same principle. It still keeps the pressure on the lock and keeps the blade from closing. Same principle and basics as the Scorpion 6. Now, the more advanced style, when you have CNC, would be this EOS. And in here, you can see it has an insert, steel insert. This is really cool because now it's steel on steel. When you have steel on steel, in my opinion, you just have a better lockup. Steel on steel has less chance of getting a sticky lock. You can increase the torque without making it stickier, whereas titanium takes a little more finesse and tuning. Steel definitely helps out with that. As far as which one's stronger and weaker, that's debatable, and you can argue about it all the time. Everybody has an opinion. I think they're both great. This one's just a lot easier to work with, where this takes more time in tuning to get it right. Now, having that, principle's still the same. This relief is different. It's a different thickness than both of these, but because of the length of the lock bar, the steel insert, and how much tension's put in there, it works perfectly, and it's still the same function as the other two. And lastly, we'll go with bag knives. On this one, still a frame, milled, different thickness than these other three. It's milled differently than these other ones, and this is also just a separate piece from the scales itself, but it still has a lock bar. You still have your milled relief, and then these have an over travel guard built into them, so you can't unspring that lock tension, as well as the actual lock engagement itself. Same features, but everything is different because every knife is different. So that's a key component in all of these, is they're all different because that's what works with this blade on this knife. And even within our own company, we don't do them all the same because they don't work the same for each individual knife. So that's the basic function, design principle behind lock reliefs. This EOS, yeah, it also has, you can't see it internally, you can hear it. It has an over travel guard as well that's built into the system, so you can't unspring the lock. So there's frame lock. Design, check. Over travel guards, we covered it. Nice thing about over travel guards is they keep you from unspringing the lock. If you pull too far and you unspring the tension, then you're gonna have a weak lock, and it's your fault because you unsprung it. The reason that happens on our knives is a lot of people like to unlock it with their thumb, kind of grandpa style is what I call it. So when you push with your thumb, you can have a tendency to push too far. And once you unspring it, it's toast. The knife has to come apart to reload. So what I always do personally and recommend is more of a claw grip. You're using the knife, you're cutting whatever you have to cut, and then when you're done, you put your thumb here and you unlock it with your pointer finger. Your thumb works as its own over travel guard, and then you can close it. I usually drag it against my pants to get going, and then it's closed. That's what I use as an over travel. But a lot of people like to unlock with their thumb, which is a common issue in unspringing your lock. Lock inserts, we talked about that. They're awesome, not totally necessary in tuning the knife, but it definitely makes it faster to tune the knife in general. And then you don't need to buy one of those expensive carbonizing machines. Early versus late lockup, reasons for lock slip, lock angles. We'll start with lock face angles first. When you're looking at lock face angles, everybody's different. I don't know how these other makers do it. I'm just going to go by look. It looks like this one's done on a flat plotting. This one also looks like it's been done on a flat. This one looks like it's been done on a wheel, and this one has been done on an 8-inch wheel. People have different reasons for doing it, and I'll kind of explain why. If you're grinding the lock face, you have a flat on the blade. When the lock bar comes over and hits it, you're hitting this angle. As this starts to wear down and the lock bar keeps coming over, it's going to keep hitting the same angle. Now, other people like to use a wheel. This is a little dramatic, obviously. And then their locking gauge is here. But over time, as this wears away, it's going to increase the angle. Now, sometimes you'll see videos where people get their knife and then they push this to see if they can get it to reach the other side. That's lock creep, as I call it. So if you're pushing to force it to go to the other side and it's doing that, it's probably just a flat ground one. This increasing means the harder you push, the harder it's going to fight back and the harder it's going to move over. There's a preference between why people like to do a wheel versus a flat. It's all up to the maker, what works best for them and their warranty returns and things like that. I don't think there's a right or wrong if you do it right. This, on a wheel, you're more tendency to get lock stick later on in life. This one's nice because if you were to plot this on a graph, it goes up at the same versus this. So this is going to give you stable increases. This is going to increase more over time. It's all up to the maker how you want to do it, really. So that's lock face angles. To simplify some of the issues with it, if the maker goes too flat on the lock angle and the lock bar comes over, this is going to be able to do that lock creep where you could push it over. If you go too steep with the angle and the lock comes over, this contact isn't going to create enough friction and it's going to slip off. And if it slips off, then the blade can close on your hand and you have other issues. So there's a sweet spot in there of what this angle should be. And there's no black magic behind any of this. It's what works for each knife. We have some knives that work better with steeper angles and some that work better with more shallow angles depending on blade size. So that's totally up to you. Okay, lock face angles. So the next one, reason for lock slip, rock stick, and early versus late lockup. For this one, I'm going to need a whole nother piece of paper. So let me go get another piece and we'll get into it. Okay, for the first thing I'll go over, we'll go over early versus late lockup. So early versus late. I'll explain this by the percentage rule. So 0 to 100%. Let's see if you can even see that. I'm going to go bigger. All right. 0 to 100% lockup. And what that is when you're looking in the knife, you have part of the frame here. You have your bearings or your washers. The blade goes up that way. Your bearings or washers on the other frame side. And then you have your lock angle, the ground in here, and then your lock bar comes over. So where the blade is here to here, this section, just the blade, you're going to call that 0 and this 100. So if I were to blow that up, this is where that lockup grind is. That's your 0%. That's your 100%. So if the lock bar were to come over to here or here, this is where you say it's got 50% lockup. Yeah, it's got 10% lockup. That's what that means. Now, if you want to get super sciencey with it, you have this fancy little measuring device. You can measure the blade, say, it's 200. My lock engagement is, I don't know, about 50 out of 200. So lock up engagement, 50, 200. do the math. Was that 25? That's where the engagement is. So one of the questions is early versus late lockup. Some say it's better, some say it's not. So there's a lot of variables into this equation and whether or not that works or not. Early lock. There's only a few ways that could work versus not work. If you have light tension, it's not going to work. If you have wrong tension, it's not going to work. The reason I say wrong tension is titanium is a memory metal. And what that means is if you bend titanium and then just leave it overnight, it's slowly going to work its way back. So what you need to do is bend it beyond the point that it needs to be bent and then give it a new memory by slowly bringing it back. If you don't do that, if you bend it back too far, if you unspring it with your thumb, now the tension isn't actively pushing into the lock. So if it's not actively pushing in there and you have light or early lockup, it's going to break. And you'll get that to where it flexes, slides, and breaks. If you have light tension, it's just not going to have enough oomph to keep it over. So light tension or the wrong direction, really, of tension, it's not going to work. Now late, that's your early. So if we go into late lockup, some people consider 50% and on late lockup. Now this is all opinion. That's the problem. Because you have some makers that'll be like, well, if it's not in this range, then it's junk. And that's not entirely true. It's just that's where they do theirs. It doesn't mean everybody else is wrong. And then you have some people that say, well, it needs to be 50% or higher in case it's under heavy use, or you're wrong. So now everybody that's over here is scared. Though it all depends on what the maker is trying to sell you. And really none of that matters if this is all jacked up. So it's just basis of opinion. But if you have an early lockup, you got to make sure you have the right tension and you got to make sure it's torqued the right direction. Now, late lockup, if you want to look at like pros and cons, your pro, if it does have the right tension and if the tension is facing the right way, it's going to be more stable over time. So that stability under heavy use when you're really prying and cranking, if this is 50%, there's a better chance. I say chance because it's not necessarily true 100% of the time. There's a better chance that lock's not going to break. Now, if you look at the con, there's less lifespan. So titanium, even the steel inserts, over time of flicking the knife open and beating it and doing, hammering, whatever you do with it, over time, it's going to keep hammering the titanium. Even with the steel inserts, it's going to start hammering the steel, and this lockup is slowly going to work over. The idea being, no matter how long you have the knife, eventually it'll get to the point where this touches the handle side. The blade still isn't going to be able to close on your finger. That's the idea behind it. So if you purchase it brand new and it comes at the 50% range, the lifespan is shortened. Now by how much? I don't know. How often do you use your knife? If you use it every day, maybe you'll see it in your lifetime. If it stays in the gun safe most of the time and it's at 50%, probably your grandkid may notice that it starts to move over. So one is the lifespan of that remaining 50%. Another one is if the lock angle isn't steep enough. So if you have kind of a shallow lock angle like this and you're already at 50%, you might be able to apply pressure and get it to slide over to the handle easier because you don't have kind of this buffer area for fluff. So if you screw up the lock and you land late, then you're gonna be able to push it over to the side. It kind of depends on how you ground your lock face. So it's all opinion, early and late lockup. For my knives, I like to start somewhere in the 5 to 15%, but that depends on the user. If I think it's going to see heavy use, I like it in the 5 to 15. If I think it's going to see EDC use, just riding in your pocket, I like 15 to 30% lockup. If I think it's not going to see a lot of use at all, kind of like your Sunday carries and stuff like that, anywhere between 30 to 50%, I think is fine. And that's what I think on my knives. Other people don't think that, and that's totally fine. It's just an opinion. As long as the tension's correct and the tension's pushing the right way, none of these numbers really matter. Now, some people say if it has really, really early engagement like this, what if you're, really putting a lot of impact on it? There's more of a chance it's going to shear over. That's correct. But you shouldn't be hammering with a knife. That's not what they're designed for. I'm not going to get this paintbrush and try and draw with it, okay? Because it's a paintbrush. It's not designed for that. I'm not going to get this pick and try to use it as a pry bar because it's not made for that. So I'm not going to get a knife and purposefully try to get it to break because that's not what it's designed for. So the argument of, I think it's going to shear if it gets too much force, that's because you're using it wrong. Learn how to use your tools. Another reason that idea is kind of wrong is the whole purpose of a frame lock is the harder you're gripping this, the more you're using it, the more you're putting pressure on that lock bar too. So if you're really prying with it, you're actually creating a tighter lock. Not when you're hammering or trying to force fail it. Because again, that's not functional. This isn't how you use a knife. Just like that's not how you use one of these picks. So use your tools appropriately, or else I'm just gonna have to call you names. So 5 to 15%, I don't think there's anything wrong with it because you shouldn't be using it as a hammer. When it comes to late lock, I don't think I have anything that's even remotely close to 50% here. Maybe 30, maybe. But I really don't. I don't mind a late lock. As long as it's not over 50% when I get it brand new, I'm totally cool with it. And if it's over 50%, as long as the angle and the tension's right, I still don't care. It all depends on how these two are appropriate. So, again, that's my opinion, and it all depends to the user. If you like this, then maybe you should request that when you purchase the knife. If you like this, request that. If you like this, request that. And then understand there's still a really good chance people may not be able to get that for you. And that's just the way handmade knives are, unless you want to get them made by machine where everything's cookie cutter and exactly the same. Then maybe you can get that to nail in there. So early and late lockup, that's that. Now, on to the last question here. This is reasons for slip. So lock slip, lock rock, lock stick. Okay, a lock slip. What a lock slip is when you apply pressure, or maybe you're cutting in the upward direction with it, and you can see the lock bar start sliding off of the lock face. More slipping, kind of like greasing off. That's called lock slip. Now the reason the lock slips, going back to what we talked about earlier, you have this angle, and then you have the lock bar angle, and this is slipping off of the lock face. So this can be caused by, let's just call it dirty. It could be dirty, could be oil on it. A lot of people are starting to drop lubrication into this, and that's going to create oil on the lock face. This is a friction lock. Friction, oil, that makes sense? Okay. So it could be dirty. It could be the wrong angle. Maybe not necessarily wrong, but it's not right for whatever's going on here and is creating slip. And another one, lock bar tension. So if this lock bar isn't pushing over appropriately, it could cause that to slip. Now it could be that way from the factory. Maybe it wasn't loaded up enough, or maybe it's because when you're unlocking it, you pull too far on this and you actually relieve the tension out of the spring. That's the more common cause for lock slip, is people unspringing the lock bar tension. That's actually the number one reason for our returns, is people unspringing the lock bar and too much oil on the lock face. That slip. Lock rock. This is a big one. Some people will get the knife and they'll go like this. You could hear it clicking. Or you can grab it just a little bit and go like this, and you hear a click. This one's a little trickier to explain, so we'll do a side view here. Here's your pivot. I'll draw it straight off of this so everything makes sense. There's your pivot. Here's your lock bar. Your relief. And then on the blade, you have your grind for that lock angle. So there's a couple things it could be. One, your pivot hole has a little bit of play in it. That could be caused by wear, especially if you put oil, too much oil into this pivot. It starts to attract dirt. Dirt and oil become sandpaper, and tight tolerances end up getting bored out, so you can get rock. This slop and play gives you that click, because inside of here you got a stop pin that rests on the steel from the blade here, and this clicks. Now another one, if you think of this as a wedge, so you have the lock face of the blade here, and then that's engaging like that on the lock bar. This is called your angle of interference, for those of you that are curious. So when you create this weird pressure where you're trying to force close it, all the pressure's going this way, and a wedge, if you look at force applications here, this is rotating around this pivot area. This is wedging this direction, because that's what wedges do. They slide kind of like tectonic plates. They wedge. Well, that wedge, as it's wedging harder from that pressure, creates a gap here, and now you get a click. If there's not enough lock tension, you'll notice a click, because it's not actively pushing against that. Again, the primary cause is because the user's unsprung this lock bar. That's the primary cause. So if you unlock it with your thumb and you start to notice this issue, you've probably unsprung it. It needs to go back to the maker. Sometimes it's because there was too much oil in here. Sometimes it's just because it's wedging. Again, the easiest way to get rid of that is to make this so tight that this can't move, but then the knife won't flip. So you're going to lose the ability to open the knife, just to get rid of an issue that's not an issue other than just you not liking a little metallic sound from steel on steel. That's lock rock. Lastly, lock stick. Now it's funny, slip and stick actually have some of the same reasons. Lock stick is when the lock bar binds up against the lock face, and you can usually hear it when you're trying to unlock it. You'll hear this where it lets go. One of the number one causes for lock stick is dirty and oil. Now I know it seems weird, because you think the oil would be slippery, but oil attracts dirt. Dirty lock faces create stick. The easiest way to get rid of that, especially on our knives, you have an exposed lock face here. You get a clean Q-tip and you can just come in here and roll it. Get any of the oil and debris off of there and you're good to go. If it's worse than that, you may actually want to wash this in the sink because you probably got oil on the lock face, on the lock bar itself, and it's going to keep getting on here. So you're going to have that issue. That is the number one cause of lock stick. Another reason, too much tension. So if you've loaded up the lock bar to try and get rid of lock rock, now you're going to have lock stick. So if people start complaining about lock and you go to create this stick, they kind of have to choose between one or the other. Do you want lock rock or lock stick? Because that's the only way it's going to get rid of that issue for you. So you kind of have to make a decision. Do you want to have stick or rock? And just kind of work with it that way. Can you get rid of it? Yes. It usually means the knife needs to be broken over time. You carbonize the lock face, you keep this clean, and you can sit there and break the knife in. It's a lot better if I don't know, I like to break in my own knives. So I think it's cool if the purchaser of the knife breaks it in. But if they don't want to, you could always do it and just get rid of the stick by cleaning the face and letting it break in naturally. Yeah, too much tension, just load it up too much, that can create stick. And then also, the same as slip in the last here, is this ground at the wrong angle. So too steep, or sometimes they weren't paying attention on water jet and this is reverse cut. So you'll notice there's a bigger gap here and maybe they don't machine or grind that lock face to make sure it's the same. And now they're actually meeting up just like this drawing here where they bind up at the perfect angle where they meet each other. And that'll make that sticky too. It can also create an issue over time where it can go all the way to the handle side. So lock stick, it's probably dirty or there's too much tension because they didn't want the rock or it's the wrong angle. Again, sticky lock, keep it clean. Another way, you get a mechanical pencil. You can see where this line is. You just really lightly scribble in here with that mechanical pencil and the graphite works as a lubrication. And that'll. So thanks for tuning in, everybody. I know there was a lot of information. It's kind of like drinking out of a fire hose. So if you have any questions about lockups, feel free to reach out to me. You can hit me on Instagram, although that usually gets buried. You can send us an email or just comment right here on the YouTube video, and we'll be able to kind of dial into if you're having any specific issues. Lockups is something that I've been able to work on for the last 5 years. There's a lot of information in there. There's a lot of different variables between angles of interference, the lockup angle itself, whether you do flat, whether you do hollow. Some people like to use 60 grit belts, 80 grit belts, work up to 120, 400, polish. Some people like to CNC their lock faces. There's a lot of different things you can do, which also means there's a lot of different variables. If you have internal stop pins, external stop pins, if you're doing steel inserts, if it's just titanium. So there's so many different things. Even the steel itself can all add to all these things. So there's a ton of information. There's a lot of different things that can go wrong. There's a lot of different things that may work for some people that don't work for others. So if you have any questions, feel free to reach out and we'll be able to field them kind of in the best way we know how, based on the experience that we have. Other than that, really appreciate you tuning in. I know it was a lengthy video. I know there's a lot of information, but thanks for hitting us with these questions. We hope that we're going to be able to provide more knowledge, because the more people know, the better it's going to be for the entire community, and just the better it's going to be for everybody. So I appreciate it. Happy 3-year anniversary to Scorpion 6. We couldn't do it without you guys. Much appreciated. And we'll keep doing these videos every Tuesday, just answering people's questions and going in depth about kind of how all this works. I'm not going to show you how to do it, but I'll at least explain the theory behind it. So thank you very much. Appreciate it. Till next time. See you.